Hello and welcome to m252 here at Cañada College. My name is Lapuz. In this video we'll be doing checkpoint 6.15 coming from section 6.3. It says to find the Maclaurin series for f of x is equal to cosine x and use the ratio test to show that the interval of convergence is minus infinity to infinity. Show the Maclaurin series converges for all x, converges to cosine x for all real numbers of x. So in one of the previous checkpoints, we did talk a little bit about a few series that's going to be important for us and probably worth trying to remember. We have the geometric series, we have the exponential, the sine, and the cosine functions. We can go ahead and derive this. Let's go through the motions of deriving this, and we'll talk about the series itself, and after that let's find the interval of convergence. So for us to do this, I think we're going to need to find derivatives. If this is your original function, your first derivative is going to be, it's a Maclaurin, so it's going to be well, we'll evaluate it at 0 a little bit later. So this is going to be negative sine x. The second derivative would be negative cosine x, and then the third derivative will be positive sine x, and then the fourth derivative will be positive cosine x. And you see we're back to the same function. So I think the fifth derivative here will be the same thing. And I'll just put dot 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 dot, etc., because it just repeats itself. So we want to put 0 in there, and if we put 0 into the cosine, this will give us cosine of 0, which is 1. F prime of 0 would be this derivative. Sine of 0 is 0. F double prime of 0 would be a negative 1, and F triple prime of 0 will be a 0 again. Now when we get to the fourth derivative evaluated at 0, that is back to the cosine, which is 1 again. And the fifth derivative is going to be 0, because that's the sine again. And the sixth derivative will be equal to negative 1. And the seventh derivative will be equal to 0 again. So again, dot dot dot, you'll see that pattern. So from here we can set up our f of x, which is equal to cosine x, and this is equal to this series. It'll start off with a 1, and then plus 0 times x minus, well, I'll just say x. And then it becomes a negative 1, and then this is going to be an x squared because it's a second power, and then we have 2 factorial, and then we have a 0 again for the third degree polynomial, and then this becomes a positive, and we're at the fifth level, no, the fourth level now, so this would be x to the fourth over 4 factorial, and then 0 again, and then a minus at the sixth term, or the sixth polynomial, and then 0 again, and then the eighth will give us back to a positive 1, 8 over 8 factorial, etc. Okay, so we can write this out as 1, and then negative x squared over 2 factorial, plus x to the fourth over 4 factorial, minus x to the sixth over 6 factorial, and dot dot dot. So we want to eventually write this as a sum in terms, and it's always nice to start at 0, and then we'll have a negative 1 to the Let's call it to the nth power, because the 0th power, the first term, is positive. And then we have, it goes by 2's. So we have x to some power and then something factorial. And these two numbers are going to be the same. So I think 2 to the n, if we start with 0 factorial, we have x to the 0, or I'm sorry, if we start off with n is equal to 0, we have x to the 0, which is 1, divided by 0 factorial, which is 1. And when n is equal to 1, then we have x to the second power divided by 2 factorial. And then this would be a negative because n is equal to 1. So I think we got our formula here. This is a good formula for our cosine. Okay, now that we have that formula, let's go ahead and use the ratio test to show that the interval of convergence is all of real numbers, or the radius of convergence is infinity. So we do that by using the ratio test. And we'll take the ratio test, take the limit as n approaches infinity of, we'll ignore the negative because we're going to take the absolute value anyways. And the top term would be 2, or I'm sorry, x to the 2 times n plus 1 divided by 2 n plus 1, 2 times n plus 1 factorial, divided by x to the 2n over 2n factorial. All right, let's see how we're going to cancel. We'll take the limit as n goes off to infinity again, and then we have x raised to the 2n plus 2 over 2n plus 2 factorial times 2n factorial divided by x to the 2n power. Okay, what are we going to have? So in terms of the x's, we're going to have 2 more x's here than in the denominator. So that will leave us with an x squared up on top. So we'll have the limit as n approaches infinity of x squared in the numerator. Now in the denominator here, this is going to be 2n plus 2 times 2n plus 1 times 2n, and then the factorial part of that. So we see that there's a 2n factorial that will cancel, and then you still have a couple of terms that have an n in the bottom. So we're going to get a 2n plus 2, 2n plus 1 after we cancel everything out. All right. Now, it doesn't matter what x is, because it's not dependent on the n, and also it's squared, so we can technically lift the absolute value. But more importantly, what happens here as n goes off to infinity with the rest of this is that you have a denominator that's going to go off to infinity, and then that would make the whole term go to 0. So this whole term goes to 0, and that's your L. Now normally we would have an x here, and then we'd have to solve for values for x that would make this work. But since this is clearly less than 1, this is going to converge. So by the ratio test, this is going to converge. Limit is 0. So this is going to converge for any value. Your radius of convergence is infinity. Usually we think about the radius of convergence as a reciprocal of this limit, and so in this case it's going to be infinity. So the interval of convergence is going to be going from minus infinity to infinity. All right, so okay, I hope that helps. We got our series and we did the ratio test and we got this to be equal to 0, and so we got the radius and the interval convergence figured out. I hope that helps. Good luck.